Hello and welcome to the Friday, September 12th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu undergraduate certificate program in cybersecurity fundamentals. Today's diary is an update from Guy about the DShield SIEM that, Guy maintains, and actually he created it as well. One of the great things about running a honeypot is, awareness about all the attacks that your network may be exposed to. This SIEM provides you with a real pretty graphical user interface summarizing the attacks that are hitting your honeypot and allowing you to essentially dig into the data more easily without having to break out your command line skills. And just the visualization itself is pretty nice and also provides quite a bit of value, I think, particular to better understand how the attacks are breaking down. There's geographic maps that you can look at. There are various sort of port statistics and such that are being summarized here. Now, the nice thing about this SIEM is that it's actually entirely inside Docker containers, and that makes it really easy to update. You essentially just remove the old Docker containers and then create new ones, and you are up to date. So if you're using this tool, take a look at it. If you're not using it, take a look at it and see if you like it. It does require a little bit more processing power than you usually have, like on the basic Raspberry Pis. But if you're running your honeypot inside a virtual machine or on a little bit of more powerful system, it'll certainly work. It uses Elk, Elasticsearch, Logstash, Kibana, and those familiar with these tools will recognize also the overall UI that is presented by this SIEM. And yes, it's becoming sort of a recurring theme here that we have government agencies. Today, it's the Australian government's Signals Directorate noticing an increase in attacks against Sonicwall SSL VPNs. They're linking it to an older last year's vulnerability. The big problem with all of these compromises is somewhat twofold. First of all, of course, some devices still aren't being patched. And the second one, that's a little bit the more tricky one, is that devices are patched. But at the time they were patched, they were already compromised. The attackers either left backdoors behind, they added additional accounts, they stole credentials. So it's really important if you're patching these devices, don't just blindly patch, in particular if this is not a super new vulnerability, like it's maybe a month old or so. Assume compromise, change credentials, change passwords, change SSH keys, change seeds for two-factor authentication, and definitely do a quick review of what users are on the system, any odd binaries. Without at least some rudimentary incident response here, you're risking that the device has already been compromised, and really patching it is usually not going to evict the attacker. And a number of researchers from the US and Europe have collaborated to do a larger study on the use of keystroke detection in JavaScript on various websites. What happens here is that the websites include JavaScript that will basically record any keystroke while you're using the site. So even before you submit a particular form, the website may receive anything that you type, including things that you may then later delete before submitting a form. Now, sometimes this kind of code is being added as more something like a CAPTCHA, where they want to detect whether or not it's actually a human typing the text, sometimes sort of for simple copy-paste protection, which is an entire different story. But of course, the big problem here is that let's say you start typing your password by mistake into a username field or such. And even before submitting that password, that password has already been sent to the respective website. So there's a real privacy risk here. As a little side note to this, Had recently a student here at SANS.edu write a paper about some of these tracking technologies, not just JavaScript based, but also others like Canvas and such based, and comparing malicious and non-malicious websites. And well, the sad truth is that malicious and non-malicious websites use exactly the same techniques at exactly pretty much the same prevalence. As a user, not much you can do to protect yourself here. Something's interesting to sort of in your developer tools, in your browser, to observe the network requests. You can sometimes see what's happening there. But just be aware that this is happening. Be careful how you type, what you type, and assume that anything that you type in a particular website is being transmitted to the website, even if you don't explicitly click submit. Well, and that's it for today. Thanks for listening. Thanks for subscribing and liking this podcast. Did I miss a story that I should have covered? Please send me links to stories. Also, if you discovered something yourself, if you wrote an interesting paper, always interested to hear from authors, not so much from marketing departments alike. But anyway, that's it for today. Thanks for listening and talk to you again on Monday. Bye.